Hello, math people. This short video lesson is going to look at one of the things we've talked about in our expressions unit, and that is the distributive property. So the distributive property is a mathematical property that gives us an ability to simplify algebraic expressions. A lot of big words there, but the big name of the game here is simplifying. We're looking to take an expression and rewrite it in a different way, but in a way that it's still equivalent to the original way it was written. The best thing to do is to look at an example, but before we do, I'll also give you the written out words of what the distributive property says. The distributive property says that if you are going to multiply some number by a sum, so an addition problem, or a difference, a subtraction problem. So what that looks like, before we talk any further, would be we're multiplying something. I'll start with letters. We'll multiply something by something that's being added together, or alternatively, multiply something that's multiplying by something else that's being subtracted together. So A, which is representing some number, multiplied by the sum of B and C, or A, some number, being multiplied by something minus something else. So you can rewrite an expression that looks like either of these, and the way that you do that, let's read. It says, multiply each term that's in the sum or the difference. So in these examples, that's the B and the C, the things inside of the parentheses, by the number outside of the parentheses. So let's look at this example first. This is saying A times this whole thing, B and C. A multiplied by B and A multiplied by C. So we could rewrite this as A times B plus A times C. Both of these expressions mean the exact same thing. They're just written different ways. But if we gave a value to A and a value to B and a value to C, like if we said A equals 1, B equals 2, C equals 3, and we evaluated both of these expressions, they'd both end up being equivalent to one another because they mean the same thing. They are equivalent. It works the same way if you're subtracting inside of the parentheses. This is saying A times multiplied by this whole thing, this whole expression, A times B and A times C. So we could rewrite this as A times B minus A times C, and they mean the same thing. And so here, let's go to some examples of where you would and how you would use this to simplify or rewrite an algebraic expression. So 4 times the sum n plus 5. Distributive property says you multiply the number on the outside by the pieces of the expression that are inside of the parentheses. So this would be 4 times n and 4 times 5. 4 times n plus 4 times 5, which you could rewrite as 4 times n plus 20. And this expression here, 4n plus 20, is the exact same thing as the original, just written a different way. So both of these things are equivalent to one another. But we're trying to look at ways that we can write expressions in a simplified way, getting rid of the parentheses. And this is a way that you can do that using the distributive property. We'll look at a couple more examples, and then I'll wrap up this quick video lesson. This second example, pretty much the same thing as example A, just with some different numbers involved. So we're going to multiply the outside number by everything inside of the parentheses. Why? Because that's what it says. It says 12 times 2y minus 3. Remember, anytime you've got a number that's just directly next to something else, for example, here I've got 12 just right next to the parentheses, even though there's not an operation written in there, in math we know that that means there's multiplication happening. 12 times this whole thing. So I'm going to distribute 12 times 2y, 12 times 3. 12 times 2 is 24y minus 12 times 3, which is 36. And this is my simplified, rewritten version of the original expression. Not too bad, right? Let's look at a couple more examples. This next one, it's the same thing, but the number that is being distributed, so that I'm talking about the number outside of the parentheses, is a fraction, 1/2. That changes nothing. That does nothing different. We're still just multiplying this outside number by everything that's inside of the parentheses. So 1/2 times 6y minus 1/2 times 2z. And then just do the actual multiplication. 1/2 times 6 is 3, so I've got 3y. And then 1/2 times 2 is 1z. Or some of you might write this as 3y minus z. You just don't include the 1. Both, I mean, they mean the same thing. It doesn't matter how you write it. More often you'll see it written like this, so I'll write it like that. All right, let's do 2 more examples before we wrap it up. This next expression is the same thing, but now we've got an extra term involved. Instead of 2 things inside of the parentheses, there's 3 numbers. That doesn't change anything, though. I'm still going to multiply 9, the number outside of the parentheses, by everything on the inside. So 9 times 6, 9 times x, and then 9 times 2. So 9 times 6 is 54, plus 9 times x is just 9x, and then 9 times 2 is 18. And that would be the rewritten version of this expression. But look, by distributing here and getting rid of the parentheses and rewriting the expression, we could actually do something even further to simplify this particular expression. Let's look. If we used the commutative property, which says in an addition problem, you can rewrite the numbers in any order you want. So instead of 54 plus 9x plus 18, the commutative property says I could rewrite this as 54 plus 18 plus 9x. Look at this. I could do 54 plus 18. I could actually do that addition there. And I could simplify this even further. 54 plus 18 is 72. And so I could rewrite this in its most simplest form as 72 plus 9x. And how we got there was we distributed, and that gave us an expression that didn't have any parentheses. And then I just reordered the addition, and I actually did the addition, 54 plus 18, and got 72. And there we go. A simplified expression that is equivalent to the original thing that was here. Let's do one more example problem here. Let's do something that looks a little bit different. So we've got 4 times, and then inside of the parentheses, 2h minus 3x plus 6 plus 8. So this is one where pay a little bit of extra attention. You got to be kind of careful here. The reason is that plus 8 that's at the end, sometimes it's tempting when you're distributing to just go crazy and start distributing to everything. But this is 4 times these terms right here, not the term that's outside. So 4 times 2h, 4 times 3x, and 4 times 6. But the 8 is not being multiplied by that 4. It's not in the parentheses. So we're not distributing to that as well. So this rewritten would be 4 times 2h is 8h minus 4 times 3x is 12x plus 4 times 6, which is 24. And then the plus 8 was not distributed to, but it's still part of the expression, so we're going to write that down at the end. And then, just like in the previous example that we did, we can add this 24 plus 8 right here and go a little bit further. So 8h minus 12x plus 32. The 32 is coming from this 24 plus 8 being combined together. And that's the simplified version of the original expression there. So that's the distributive property in a nutshell with a couple examples to try to help you make a little bit more sense of it. As always, if you have questions, feel free to reach out, but happy mathing, everyone.